So population is another application of the compound interest formula, just like inflation. It's a really simple application where population increase percentages will be the I value, and A and P will be the size of a population, while N will be the number of years over which something grows. The background of this slide is just an image representing how the human population is most certainly growing, and I have inserted a link to an interesting population growth video by Ted Ed in the to-do list of this work for you to have a look at after you've done your maths. But for now, the only knowledge you need is this general formula, the compound interest formula. And I'm going to, just like that, I'm going to dive straight into an example. If a town has a population of 65,320, that means that's the number of people in the town, and the average growth of the population is 8.2% per annum, we need to determine the expected population of the town in 20 years' time. So when you see any sort of population question, the first thing you need to do is write down the compound interest formula. Now let's consider what information has been given to us. We have the present population figure of 65,320. We also have the population growth percentage, which is 8.2, written as a decimal, will be 0.082. And then the number of years is given to us directly as number 20. So we have a value for P, I, and N. Therefore, we can just plug it all in, whip out the calculator, and see that the expected population in 20 years will be 315,000. Don't you think that is incredible? So in the space of merely 20 years, that's a quarter of a life, a town can go from 65,000 to almost half of 100,000. That's crazy. Anyway, ready for example 2. If the buffalo population increased from 22,266 in the year 2000 to 37,500 in the year 2010, calculate the annual percentage increase in buffalo over this period. So this is exactly the same as financial monetary questions when we need to calculate an interest rate. So if you are calculating the percentage increase or the percentage of population growth, that means we're just looking for that I, and we need to be given A, P, and N values. So let's jot down what we've been given. The the principal population amount, the original population that grew was 22,266, and then the final amount, the bigger version of the population after it had grown, was 37,500. The I, that's the population percentage increase, that's what we're looking for. And the N was not given to us directly, but because we knew the years, 2000 and 2010, we can subtract those two to realize that, we're dealing with a 10-year period. So now we're going to plug all that information in. And I'm going to be very cheeky and make I the subject of the formula in one step. Before I reveal it, I'm going to go through the process. In order to get the bracket that is raised to the power of 10 alone, we need to undo the fact that it was multiplied by 22,266. To undo multiplying, you divide by that figure on both sides. Thereafter, you need to undo or reverse raising the power to 10. So we apply the 10th root. Thereafter, we subtract the 1 and we have made I the subject of the formula. If you need to do that in several steps, it's okay, you are welcome to, but please just don't round off your answers as you go. You will get your final percentage wrong. So I recommend changing the subject of the formula and only using your calculator once so that you have those full figures in the calculator and your answer is as accurate as possible. Another thing to be careful of, though, is when you plug this complicated 10th root into the calculator, before you type -1, just scroll as far as possible to the right so that the cursor can exit the 10th root sign. You'll often see that the calculator pops the -1 underneath that 10th root, which will make your answer incorrect. So just scroll to the right as far as possible and make sure the subtract 1 is a separate term to the 10th root. Then we say equals, and voila, the calculator will give you a recurring decimal. Well, no, not recurring, just a non-terminating decimal, a long decimal, and we multiply that by 100 to get our percentage. Remember to always round off percentages to 2 decimal places, which means your previous line, where it was still a decimal and not a percentage, should have had at least 4 decimal places so that you can round off correctly when you convert to a percentage. Okie doke, so now we're on to exercise 12.6. And it's only question 1, 2, and 3. Really, really easy. Off you go.